Are we live? Oh, great. All right, my name is Ryan Dooley. I am from Texas Advanced Computing Center in Austin, Texas. I'm here today to talk a little bit about the Agave Platform and how it can help you avoid vendor lock-in, give you flexibility and portability in your hybrid cloud environments, and help deliver solutions to your end-user scientific community. So if you've never heard of TAC before, I'll just give you a quick overview. TAC is about 150, 160 folks. That number is wrong every time I write it down. We have about 2 people starting every month and half of the last 10 years or so. So we're growing very quickly. We provide about 2 billion hours or so annually to the HPC community. We service the entire national open science community in the United States. So it's a public resource, public data center that we provide for the primarily academic research community. HPC, HTC, cloud, we have a lot of data, we have data-intensive computing resources, we have a whole playground full of stuff. And we are, as I mentioned, located in beautiful Austin, Texas. Now, since 2013, we started transitioning a bit. It used to be that we were just an HPC center. We started moving into other forms, other paradigms of computing because we realized that just because we had some very, very large supercomputers, it doesn't mean that everything was appropriate for that paradigm. So today we serve over about 3 billion process hours to our end users. We've had 9 million successful jobs in the last few years. We have about 10,000 students and faculty, other users that are coming in to use us, but we have about 4 to 5 times more than that are coming in through portals and gateways and alternative interfaces. And because of that, the requests, the allocations that we get in to use the resources vary from 5 to 7x depending on the kind of resources they want to use. And that's over and above what we can actually provide physically at any given time. When people are coming in, they're asking us for a lot of different things. So they want to know how to do visualization, simulation, they need consulting support, they need help porting their codes. They have a lot of different needs, and their requests take on a lot of different forms. Sometimes they just need languages installed, and those are the easy ones, but they also want a lot of different frameworks and completely technology stacks deployed on the systems because that's how they're familiar with doing their work. So as we see more and more requests come in, as we see people computing and solving their problems and really doing the cutting edge research that leads to the solutions of tomorrow, we're trying to support that. We have to really take some flexibility in how we're delivering this to our end users. So what we've done is we've spent a lot of time profiling users and figuring out the kinds of people that are making these requests, and what we've broken them down to is a handful of user personas, everything from kind of undergraduate researchers, students just trying to figure stuff out, not a lot of experience, not a lot of maturity in their overall computational approach, all the way up to directors and other organizations that want to partner with us to extend the reach of their own infrastructure and provide better and more robust services to the end user community. So addressing all of those needs is always a challenge, and we've taken a lot of different approaches to it over the years. One has been just building out, what we started doing is building out these portals. We started building out web applications that were just point-and-click interfaces for specific, very focused domains. And while those worked well, they addressed the needs of specific people and specific communities. We couldn't do that for every single group of people that came to us, right? Because we serve, maybe about 2,000 different classes of users, 2,500 different projects. That just doesn't scale. So we turned to more SaaS-based solutions, and today we provide a lot of those in the form of Jupyter hubs of various different kinds of notebooks for R, for Python, for Swift, for a lot of different languages. But we provide these as services that people can provision, scale up, and we tie them deeply into the fabric of our data center. We had people that said, that's wonderful, but I need better access, better control over even that environment. So we started deploying these alternative interfaces. This is our Jetstream interface on top of OpenStack that provides very customized, kind of orchestrated environment stacks for folks. Right? And these are users that are going to come log in, maybe deploy some applications, but need to configure kind of what's going on underneath a bit more. And this has worked out very well for us. It's tied into our 10G networks, tied into our Lustre parallel file system, It gives them global access to everything, and that's wonderful, but people still wanted more access. They wanted more control, and they wanted to be able to integrate not just into the resources that we are providing them, but resources that they're using everywhere else. All right, so we went back to the drawing board and we started looking at how we could provide these modular building blocks to folks, and so we started building out APIs. And that's really where I'm going today with this talk, is tell you a bit about the Agave platform. Now, Agave is a multi-tenant platform as a service, delivering science as a service solutions in a hybrid cloud environment. Now, what's that mean to you? Well, you can think of it like a Salesforce for science. So the difference is we're not really selling you anything, right? As much as it pains me and as much as my family would like me to, we don't actually sell this. It's fully open source software, deployed, orchestrated with Docker and Ansible. We have many public and private organizations that deploy this on-premise themselves. We can provide consulting support behind that. We also host it as a cloud service for about 13 different organizations. We're not going to force you to use it, right? There's no vendor lock-in. So if you come to us and say, hey, we have this particular domain problem, we'd like to use Agave to do it, we're like, great. Here's the documentation, here's APIs. I'll tell you about some tooling and other things that we have to make that easier, but you can treat it like a grocery store, right? Come in, take what you need, leave the rest behind, right? There's no contracts, there's no licensing, there's no access agreements. There are some best practice policies, and there are some things that we need you to understand and agree to use it, but aside from that, go wild. All right, so Agave is just a platform. Now, while we're doing this platform, we abstract a lot of stuff away, right? So when you're using Agave, we're talking about delivering a platform that abstracts your science out to a service. So there's a whole lot of bridging going on, right? Go back. There we go. We have a delay. Okay, there's a lot of bridging going on. So it's not just about can you access our data center or can you interact with some cloud service, but it's how can you orchestrate, how can you abstract out your ability to do your science independently of where it's actually running? How can the platform be smart enough to do that? And so if you look at a traditional layer cake, we're providing these layers, pretty much everything from the middle up. We're not going to spin up your VMs. We're not going to interact with your infrastructure as a service today. But aside from that, we are going to provide you a core level of services that allow you to interact with everything that may be running on those, using native protocols, using best practices, using first-class security, auditability, logging, accounting, everything with Cloud ACLs built in. So we'll give you the platform services. We'll also give you framework integrations, client tooling, developer portals, documentation, integrations with existing applications and stacks that you may already be using today. So I was going to do a big slide with a whole bunch of logos on there, but I watched the keynote and they were all in there. So think of your keynote, all of those logos that you saw in there, all of the great relationships that they had. We don't have formal relationships with those companies. We're primarily an academic organization. However, we have integrated with many of them. In fact, we do use most of them to run our own data center at very levels in our architecture. So you can think of Agave as just a way to manage your data, run your code, collaborate anywhere, and integrate with pretty much anything. A lot of tooling, like I mentioned. We have SDKs, JavaScript, Java, PHP, Perl, R. However you want to work, we can do that for you. We have command line interfaces, we have language frameworks, blah, 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 a whole lot of stuff, right? It's easy to get up and running. And it's going to work with your new and legacy infrastructure. This is pretty cool because it's zero installation, right? We manage it as a cloud service. If you or your organization were to deploy it, you would manage it as a cloud service as well. So your end users have zero install. It'll just work with their stuff wherever their stuff is at without them having to actually do or think about anything. It's a very good citizen in that. Tons of documentation. We have interactive API explorers. All this stuff just ships out of the box. Code samples, existing integrations, and we do ship a reference web application, both as a full-blown kitchen sink that we call Agave to Go, and as microsites, which are very focused, single-purpose, single-page applications that expose you to particular processes or tasks that are repetitive that you may want to just stand up a web app to do a thing for someone, right? They're really, really good for that. So why am I talking here? Well, we've been working with the Nectar Cloud, the Australian National Cloud Resource Group, here over the last, probably 6 months or so. We've been working with them to deploy Agave as a reference platform to use to interact with Nectar, but also to interact with the HPC fabric here in Australia. We've been doing Nectar. If you don't know about it, it's an OpenStack-based cloud. It's scaled across just shy of a dozen sites across the country, primarily at Tier 1 research organizations. It's used, integrated into the identity system here, and has become a very highly utilized resource, just a fundamental resource that they're building out a tremendous amount of labs, scientific environments, ecosystem tools across the entire country. So it's kind of the de facto place you go to do your research here in Australia. That being said, it's not the only deployment that we have. Obviously, I mentioned that we run a cloud instance in Texas. It represents about 13 organizations. We move, I don't know, 10, 15 petabytes of data back and forth between folks every month. We run hundreds of thousands of jobs. We have thousands of systems registered on the platform, and people are just doing some really cool stuff. When I talk about science as a service, we're talking about delivering things that are black boxes. They're questions and answers for folks, right? So if you have a scientific question and you can pose it in the form of an algorithm, you can pose it in the form of even a data set. Agave can take that and give you answers around it, right? You can frame the questions, you can frame the tasks, you can bring your own code, but it's very, very good at taking those abstract questions and turning them into answers and understanding. So some examples of this that we have, different organizations around the world. So Insides is a pretty cool project. It's out of Colombia. There's a group of researchers that are doing drug interaction screening. So they're trying to predict, based on a sequencing of your DNA, whether or not you're going to react favorably or unfavorably to a particular drug. So they built up this massive database of interactions, and then they have a ton of computational algorithms behind the scenes that run just by default and try to calculate this stuff for you. So right now they're in beta, so they have a catalog of things that you can query and you can look at as they continue to hone their algorithms. But if you talk about personalized health, personalized medicine, this is what the future of it looks like. We have, go back. So IkiY is a project at the University of Hawaii, and they are focused on figuring out how to preserve the water supply in the country. How many know there's a volcano in Hawaii? A couple of them? Yeah, so the whole thing's a volcano. And one of the fun facts about volcanoes is they are radioactive. So no one likes being near nuclear power plants, but no one has a problem living on top of volcanoes. Well, the problem is that at certain points along the islands, there is a bleed of radiation into the water supply. They didn't always know this. They know this now. So they're trying to figure out how to determine where that's coming from, how it propagates, what the danger is going to be, and how to just preserve the water supply and the safety of their people. So good projects all around, right? Some other stuff, the Arabidopsis information portal. How many people have watched movies and, in these, the labs always have white mice, right? Every time you need to do an experiment, you do it on white mice. Well, in the plant biology world, the white mice are Arabidopsis, right? It's a type of grass. So there's a group of about 12 different universities globally in, I think, 4 or 5 different countries. They got together and said, hey, this is an interesting problem. This is something that we need just to fundamentally advance the science. Let's get together. So they're working together. And the problem here is they have about 150 unique data sources. So they needed a way to pull all those together, throw them behind some user interfaces, craft alternative applications, and then provide single sign-on, kind of a common fabric to all that stuff. So when the research community comes in and says, hey, I have this question, they can say, oh, so-and-so is working on a similar problem, and you should try their approach. It's working pretty well. They can come in and without having to go through this massive learning curve, actually go in, apply that technique, get results back, and incorporate it into what they do. They can even automate that. That's Arabidopsis. Design Safe. It's a civil engineering project. Have you guys ever seen the Wall of Wind? This is my favorite facility ever. So there's a group in Florida in the U.S. who built up a hurricane simulator. So what they did is they took, I don't know if there's 6 or 10 foot fans, like ginormous Bach fans, and they built a wall of them, right? And they put those on a building and harnessed it down, full cement, steel reinforcement. And what they do is vendors and researchers come in and they build structures in front of the wall, right? You know where this is going, right? They build structures in front of the wall, and then they turn on the wall, and they crank the fans up to blow wind at 200 miles an hour, right? And then they huff, and they puff, and they see when that structure is going to blow down, right? It's the coolest thing. If you ever get a chance to go on YouTube, look at Wall of Wind. That's one of about a dozen facilities that Design Safe represents. So they need to wire those up. They have gigabytes of data per second coming out of every single one of those centers, full video, full audio, a ton of data that's being generated. Plus you have a whole community of users, multiple algorithms, multiple processing centers. All of that needs to be integrated in a way that they can present that in a consumable manner. So they turn to Agave to deliver all that to them. Cyverse is another plant biology cyber infrastructure. They have been around for about 10 years, $100 million project. They serve 40-ish thousand users worldwide. Entire thing is built on top of Agave to do pretty much everything you can imagine, from cloud storage to real-time kind of reactive computing. VDJ server is looking for, it's looking at immunology. It's trying to figure out what causes people to be immune to specific things, what causes them to be susceptible to another one. Phenomenal project. DNA Subway is teaching people about, wait for it, DNA, right? Teach students all over the place. This is actually turned into a commercial entity. They use Agave to go out and provision, run their stuff on the commercial cloud, so they have predictable costs. And Bioextract server, another great project, doing similar things. I could run through these all day, but if you guys are interested in the Agave platform, you want to see what Science as a Service means, how it can be used for you, I encourage you to go check out either the Agave instance running in our public cloud in the US, or if you are in this hemisphere of the world, check out the one running on Nectar. There's a web interface you can go and you can interact with that will do cool stuff for you and help you out. And of course, there's a lot of documentation information you can find from the associated websites. So if there's any questions, I can take those now. Thank you very much. Yes? I'm sorry, I'm having a tough time hearing. It's like there's other people talking in this room.
So I'm wondering if you have any source control elements to code this data.
The question was whether we have any source control elements to the code that people are running. Yeah, so Agave in and of itself is not a version control system. What we do is we allow you to kind of register your own applications into a catalog. We'll track the assets that run in there. We can help you provide change management, but we don't do version control. So we do have a publication channel in which we kind of snapshot them and allow you to record different unique versions over time, but we don't do necessarily rollback of one over another. So it's not a distributed version control system or source control system, but it does have a concept of kind of evolutionary code and understanding of what that means. So, cool. Anyone else?
In terms of why would they host it with you versus do it yourself, and what do you?
Yeah, so the question is, we offer hosted solutions, and some people deploy on their own. What's the trade-off? Why would you do one over the other? So kind of the first obvious answer is that it takes people and expertise and resources to run your own. So if your organization is such that you need a high degree of customization, or perhaps you need to, you have legal constraints, meaning maybe you're running a HIPAA-compliant data center, hosting a lot of medical data, which is in the U.S. is a very sensitive thing, then you would host your own instance because you want to guarantee kind of network traffic, accessibility, things like that. From the platform standpoint, it's not a security concern. It is secure end-to-end. It's used in all those environments. But you may want more than just virtual or physical isolation. You may actually want walls put around the entire thing. So that's generally the big reason that people do. All right, thank you very much.